Welcome to IB Chemistry Preparation Exam Tips for both standard level and higher level. Today I'm going to continue with topic 1, stoichiometric relationships. In our lesson today, which is part 2 of solving empirical formula and molecular formula problems taken from both paper 1 and paper 2 examples. In our previous lesson about empirical and molecular formula, I explained and discussed the meaning of both empirical and molecular. We also go through on how to calculate empirical and molecular formula. During our lesson for today, we're going to apply on more examples, more ideas, and I'm going to give you also exam tips for both paper 1, multiple choice, and paper 2 as well. So in order to start with our lesson, it is so important to go through the first idea taken for today. This is a very important past paper question, and we have a very important idea as well whenever we want to go through empirical and molecular formula calculations. We've got vitamin C, which is a compound of carbon, hydrogen, and oxygen only, which is found in many fruits and vegetables. So, I've got a sample, which is made of vitamin C. According to the question, it's made up of carbon, hydrogen, and oxygen as well. The percentage by mass of carbon, hydrogen, and oxygen in vitamin C are determined by burning a sample weighing 2 grams of vitamin C. So the mass of this sample, it is exactly 2 grams. And when the question is telling me that it has been burned, so it reacted with the oxygen, the products, of course, from burning or from combustion chemical reaction, it is carbon dioxide and water vapor as well. The masses of both carbon dioxide and water are given respectively inside the question. So I have carbon dioxide, which is 3 grams, and the water vapor, it is 0.816 grams. The molar mass of the compound equals 180 gram per mole. From these data, determine the molecular formula of vitamin C. In order to determine the molecular formula for any compound, we need firstly to start with the empirical formula. But of course, here I have an idea. In our previous lesson, we learned together that we can calculate the empirical formula if the percentages by mass of each carbon, hydrogen, and oxygen are given in the question in a direct way. But here, inside this idea, I don't have the percentages by mass of each. Instead of that, I have the amount of carbon dioxide and the water vapor masses. So we're going today to learn how can we deal with such these examples. So I'm going now to start with answering the question step by step. The first step is to calculate the mole number of carbon dioxide. So I will start with the carbon dioxide as a first product presented inside my combustion or burning chemical reaction. Of course, as you previously know, the mole equal mass over the molar mass. The mass is 3 grams divided over, I'm going to write down the molar mass of carbon dioxide, which is taken from the relative atomic masses of each 1 carbon and 2 oxygens taken from the periodic table. So the molar mass is 44.01 and your final mole number is 0.0682 mole number. Now, I'm going to focus on the carbon, which is presented inside the carbon dioxide. Since I have 1 carbon inside the formula, so I can say that the mole of carbon will equal exactly the mole of CO2 that we previously calculated, which is 0.0682 mole number. The reason behind that is, according to the chemical formula, we have 1 carbon inside the CO2. So I'm going to write this, so to remember and to write it down as a note. So because of having 1 carbon. Now, after calculating the mole of carbon, we're going to continue now with finding out the mass of carbon, which is presented inside the vitamin C sample. So the mass, it is mole multiplied by the molar mass of the carbon. So I will take my mole number, 0.0682, and I will multiply it by 12.01. Of course, in paper 2, it is allowed to use the calculator, so your final answer is 0.819 grams. I'm done with my carbon dioxide. Now I'm going to continue, but this time I'm going to start working with the water vapor, which is presented inside the vitamin C. It's the same steps exactly. So the first step is to find out the mole of water. And another time, I'm going to take my mass and I will be dividing over the molar mass of water molecule. The mass is 0.816 divided over the molar mass of water, which is 18.02, taken also from the periodic table as a final answer. It is 0.0453. I'm going now to find out the mole of hydrogen, which is presented inside my vitamin C. Now, if I'm going to look for the formula of the water molecule, I'm going to find that I have 2 hydrogens instead of 1. So in this situation, the mole of hydrogen, it will be 2 times the mole of water. So I'm going to take the 2 and multiply it by 0.0453, and my final mole number, it is 0.0906 mole number. Now, after calculating the mole of hydrogen, I'm going now to find the mass of hydrogen presented inside the vitamin C sample, which is equal for 0.0906, and I'm going to multiply it by the molar mass, which is 1.01, and my final answer, it is 0.915 grams. According to step number 1 and step number 2, from the carbon dioxide, I actually calculated the mass of carbon, which is presented inside my formula of vitamin C. From the water molecule, I focused on the number of hydrogens as mass presented inside my vitamin C. From my whole sample as 2 grams, I now know the mass of carbon, the mass of hydrogen. So now I need to go through the last step, which is the mass of oxygen presented inside the 2 grams of vitamin C. I'm going only to make a box around some important answers taken from 1 and 2. I'm going to use them later while applying on my calculations. I will need the mole number of each when working with the empirical formula. Now I'm going to continue with the third step. So for the third step now, number 3, I need to calculate the mass of oxygen presented inside my vitamin C. So 3, I have mass of oxygen presented. I need to remember that the total mass of my vitamin C, it is 2 grams. I'm going to subtract it from the mass of carbon minus or plus the mass of hydrogen. Both masses of carbon and hydrogens are already taken from step number 1 and 2. So for the mass of carbon, it is presented right here. And for the mass of the hydrogen, it is also presented right here. So I'm going to say 2 minus, I will add both masses, plus 0.0915. Using the calculator, I will find that the mass of oxygen presented in vitamin C is 1.09 grams. Now, after finding the mass of oxygen, I'm going to find the mole of oxygen. And in this situation, I will take my mass and I'm going to divide over 16. My final answer is 0.0689. 681 mole number. I'm going now to go through calculating the molar mass or calculating the empirical formula using the moles that have been done before. So I need now the mole of carbon. This is the first mole I'm going to use. I need now the mole of hydrogen. I'm going to use this as well. And I need finally the mole of oxygen. So if I want to continue now answering the question, I need to refer back to Empirical and Molecular Formula lesson, which is part 1. So I'm going now to put my carbon, my hydrogen, and oxygen. I'm going after that to put the mole number. So it is 0.0682. For the hydrogen, it is 0.0906. Finally, it is 0.0681. I'm going now to divide over this molar. So it is 0.0681. And here it is 0.0681 as well. So I'm doing now the mole ratio. And here it is 0.0681. So this is my mole ratio. So the carbon, it will be a 1. The hydrogen, it's a 1.33. And here it's a 1. If you remember, in my last lesson about empirical and molecular, I told you that it's not allowed in this situation to round the 1.33. So we need to multiply the whole numbers by 3 in order to have a whole number for hydrogen instead of having it as a decimal. So this is a 3 and this is 4 and finally we have the 3. So the empirical formula for vitamin C, it will be C3H4 and O3 and we are done. In this question, we've answered the first part of the question, into which we used carbon dioxide and we used water in order to determine the empirical formula. If I'm going to go through the steps another time, we calculated the mole of carbon dioxide. We then find the mole of carbon. we convert into the mass. We applied on the same exactly steps. We took the mole of hydrogen from the water. So here I have mole of hydrogen. Here we need to remember that it was multiplied by 2 since we have 2 hydrogens represented in the water molecule. So it is so important to remember that we should look for the number of atoms which are presented in order to know how many mole number do we have from the atom. Now we continued with the mass of oxygen. In this situation, we took the total mass of the vitamin C, which is presented inside the question, and we add the mass carbon, mass of hydrogen, and we subtract it from the total. Then we find out the mole number. For the rest of the question, we continued calculations by going through the empirical formula steps. We started with the mole number. We calculated the mole ratio. Here we need to remember that we have 1.33. It's not allowed to round, so we need to multiply by 3. And I considered this point before in my first lesson. So now I'm done with the empirical formula. Going back to the question is not asking me to determine the empirical formula. So now I'm going to continue by finding the molecular formula. So I have now the molecular formula calculations. The steps for the molecular formula: firstly, I need to find out the molar mass of my empirical, of course. Going to my empirical, this is my empirical. So I have 3 carbons multiplied by 12.01 plus I have 4 multiplied by 101, and finally I have 3 times 16, and my final answer, it is 88.07 gram per mole. Now, after calculating the molar mass of the empirical formula, the second step is to divide the molar mass given by the question, which is 180, over the molar mass of the empirical formula, 88.07, and the final answer is 2. Now the third step is to take the 2 and to multiply it by the empirical formula. So your final answer will be C6, H8, and O6. This would be the molecular formula of the vitamin C. Now we're going to apply on another question using the same idea. We have quercetin consists of the elements carbon, hydrogen, and oxygen. The mass of the whole sample, it is given as 1 gram. And we have here the carbon dioxide mass besides the water mass. So let's start with A, which is determining the empirical formula of this ester. We're going to go through the same steps exactly, but we will try to be faster a little bit. So we're going to start with the mole of CO2. We will take the mass and we're going to divide it over the molar mass, which is 44.01. With more practice on carbon dioxide and water molar mass, so you will memorize that it is 44.01. Using the calculator now, your final answer, it is 0.0609 mole number. Now we know also that a mole of carbon, it will be the same exactly as the carbon dioxide. So it will be 0.0609 mole number. Now we will continue with the mass of the carbon. So I'm going to take my mole number and I need to multiply it now by the molar mass of the carbon, which is 12.01, and my final answer, it is 0.731 gram. After calculating the mole and the mass of carbon, I'm going now to the second step. We're going to start working on the mole of the water. So we will start by mole of H2o. We will take the mass, which is given inside the question, which is 0.657, and we will divide it over the molar mass of the water molecule, and the final answer would be 0.0365 mole number. Now continuing with the mole of hydrogen, we need to multiply by 2 since we have 2 hydrogen atoms. 0.0365, and our final answer is 0.0729. Now we have the mole number. We need to continue by the mass of hydrogen. So we will multiply by the molar mass, so 0.0729 multiplied by 101. And our final mass, it is 0.0736 gram. Now we are done with both the carbon and the hydrogen. So now we need to continue with the oxygen. If you remember from our previous example, we need firstly to find the mass of oxygen. For the mass of oxygen, we will take the total mass of the sample, which according to the question is 1 gram, and it is presented right here. This is the mass of the sample. Now we're going to subtract it from the masses of both the carbon and the hydrogen. So the carbon, it is 0.731 plus the 0.0736. So your final answer, it will be 0.1954 gram. Now you calculate the mole of oxygen by dividing the mass over the molar mass, which is 16, and your final answer would be 0.0122 mole number. Now I'm going only to make a circle on the mole numbers that we're going now to use in order to further find the empirical formula. From step number 1, I need to take the mole number of carbon, which is presented right here. I need to take the mole number of hydrogen, which is also presented here. I need also to take the mole of oxygen, which I have it in step number 3. Now I'm going to put the atoms beside each other, and I will put now the mole. For the carbon, it is 0.0609, and for the hydrogen, it is 0.707, and for the oxygen it is 0.0122. Now we will go through the mole ratio, so we will divide over the smaller. you can find that the smaller is, of course, the oxygen mole. So I'm going to divide over the oxygen mole number. So this is 0.0122. This is 0.0122 and another 2. So when you divide, this will become a 4.99, so it is approximately as 5. El hydrogen, it is 5.9, so it is approximately at 6. And the oxygen is 1. So my empirical formula as a final answer is C5H6 and O. This question can be later taken as a multiple choice question, and we're going to go through the steps when you want to go and to answer the empirical formula using paper 1 as a multiple choice. It will be little bit easier, and I'm going to give you some steps while applying on such these types of questions for paper 1. Now, the last question for the same idea that we're going now to answer together, it is another time empirical formula calculations, but we will take this question from May 2021. This is one of the past papers question taken in 2021. A 4.406 gram sample of a carbon, it contains only carbon, hydrogen, and oxygen, and it was burned in excess. You have the CO2, you have the H2o. Determine the empirical formula of the compound using section 6 of the data booklet. When the question is telling me using section number 6, this is for the periodic table actually. So you will be using it in order to take the relative atomic mass. So let's start together. We will start firstly with the mole of CO2. So it is 8.802, and I'm going to divide it over the molar mass, which is 44.01, and the final answer, it will be 0.200 mole number. Since the mole of carbon it's the same as the mole of CO2, so I'm going to go to the second step direct, which is finding out the mass of carbon. So for the mass of carbon, I'm going to take my mole number, which is the same as above, and multiply it by the molar mass, which is 12.01, and your final answer is 2.402 grams. Now continuing with the second step, into which I'm going to calculate the mole of H2o. So I'm going to take my mass of the water, which is 3.604, and divide over 18.02, and my final answer, it is 0.200 mole. Now I'm going to go through one step for mass instead of two steps. Here I need to remember that the mole number should be multiplied by 2. So I'm going here to multiply it by 2, only to remember. So this is 2 for the hydrogen mole number, since I have 2 hydrogens. So in this situation, I will continue my question, which is 0.4, of course, multiplied times 1.01. And your final answer is 0.404 gram. Now the third step is to find out the mass and the mole of oxygen. So let's start with the mass of oxygen. you will take the total mass of the compound given inside the question, 4.406, and I'm going to subtract it from the total masses, 2.402 plus 0.404, and as a mass of carbon, it is 1.6 gram. Now I will continue with my mole number. I'm going to take my mass and I'm going to divide over the molar mass. And your final answer is 0.1 mole as oxygen. Now, after calculating the mole number of each, so we can continue with the empirical formula calculations. So I have the carbon, I have the hydrogen, and I have the oxygen. The mole of each, I have 0.2. For the hydrogen, it is 0.4. And for the oxygen, it is 0.1. Definitely, I'm going now to divide over the smaller, which is 0.1. So I will find that I have 2 carbon atoms and I have 4 hydrogen atoms, and finally I have a 1. So my empirical formula, taking into consideration these ratios, it will be C2H4 and an O as a final answer. Now I'm going to go through the B part, which is determine the molecular formula of this compound if its molar mass is 88.12. So we need to start firstly with the molar mass of empirical. I'm going now to put a final answer. You have 2 carbons, 4 hydrogens, and 1 oxygen. So your final molar mass is 88.12 gram per mole. Now you will divide this is the molar mass given for the actual. In molar mass, it is 44.06. Now we will take the molar mass, which is given inside the question, 88.12, divided over 44.06. And this one will give me a 2. So now I will take my 2 and multiply it by my empirical formula, which is C2H4O. And my final answer, it will be C4H8O2. So this is your final answer. If you look at the total marks given for the question, you're going to find that B part is out only of 1 mark, which is based on your final answer. So all the steps given for calculating the molecular formula, it is based on your final answer. And if I want to go through the empirical formula, the first step calculations, in 2021, the question was out of 3 marks. Talking about the 3 marks, so we need to remember that all the calculations related for the mole of the carbon dioxide and the mole of water, besides finding the mass of the carbon and finding the mass of hydrogen, taking into consideration how many mole number do we have, it's all as 1 mark. You can take it either from the mole calculations or from the mass calculations. But for the mass of oxygen, continuing with the mole of oxygen, it is taken with another second mark, and then continuing with the mole ratio and writing your final answer, taking into consideration the correct mole ratio presented for the atoms and specifying the empirical formula, it is out of another 1 mark. I'm going now to continue with some multiple choices related to paper 1. As I told you before, I need to give you some study tips that will help you when reading the questions for multiple choice and paper 1, so to be familiar on how to think and how can you obtain your final answer. On analysis, a compound with its molar mass of 60. Remember that this molar mass, it is the actual molar mass of the molecule that we have. It was a 12 carbons, 2 carbons, hydrogens, and 16 oxygen. What's the molecular formula of the compound? One of the ways into which you can calculate the molecular formula is to go through the empirical formula calculation. You take the masses, you divide over the molar mass to find the mole, then the mole ratio, and then you go through the molecular formula. This is one of the ways. But if you want to do it in a simpler way, you need to remember that the actual molecule I'm looking for, it should be a 60 molar mass. So another way of thinking, you can find out the molar mass of each A, B, C, and D, and the molar mass, which is 60, it will be your answer. And here, when you want to calculate the molar mass, you can simply take the relative atomic mass as rounded. So for example, if you are talking about CH2O, it's a 12 carbon, 2 hydrogens, and 1 oxygen. So it's a 12 as a relative atomic mass, 2 times 1 and 16. And your final answer here, it will be a 30. Now for the molar mass, for the B, also it's a 12 plus 4 plus 16. So it is the 32. Continuing with the molar mass of this one, it will be 44. Here you need to remember that 2 times 12, it's a 24, plus 4 plus 16. And finally, you have a D, the molar mass. You have 2 times 12, which is a 24, plus 4 plus 32, which is 60. So based on this way of thinking, you're going to find that the molar mass of 60, it's for the D. And this is your answer. Of course, as I told you before, you can go through the empirical formula calculation into which you can put the carbon, the hydrogen, the oxygen beside each other. You take the 12, you take the hydrogen as 2, you have the oxygen as a mass. You can later continue by divided over 12, over 1, over 16. This could be also another simple way. Since the numbers that you have, they are so easy given. So this is 1, this is 2, this is 1. So your empirical formula, it will be CH2O. But this is your empirical. So you will not stop at this step and you will continue your calculation by taking out the molar mass of the empirical, dividing 60 over the molar mass, finding the number, which will be a 2 another time. So if you want to find the molar mass of this compound, it will be equal for the 30. Then you're going to divide 60 over 30. The answer will be a 2, then 2 multiply, and it will be the same answer. Continuing with question number 2, there is another idea here. A compound with a molar mass of 102 contains 58.8% carbon, 9.8% hydrogen, and 31% oxygen by mass. What is its molecular formula? Taking AR as a relative atomic mass, it is given. Now, if you want to go through the percentages and to calculate empirical formula step by step, in my opinion, in paper 1, if you want to deal with these percentages, it will not be easy at all, since you will take 58.8 divide over 12. And you need to take 31 divide over 16. And this maybe will take from you a lot of time. So as a first step of thinking, I need to remember that the molar mass that I'm looking for, it is 102. So I'm going now to start with the molar mass calculation for each of A, B, C. Perhaps one of them, is 102. So if it's 102, definitely I'm going only to circle the answer. So it will be very similar to the previous question, but maybe here there is another idea. Here I have the molar mass after calculation 102, but here I have it 104, so it is incorrect. For the third, it is another 102. And finally, this is 102. So in this question, it's more difficult than the previous one, as in this question, we actually have 3 different answers with the same molar mass given, which is 102. So I'm sure it's not a B, but is it an A, is it a C, or is it a D? So now I'm going to the second step of thinking. I'm going to look at the different percentages given. You will find, for example, that you have 14 hydrogens here, you have another 14 hydrogens here. So the number of hydrogens presented, it's the same as A and D. So if I want to focus on the percentage of hydrogen, this will not give me any indication about your final answer. So I'm not going to go through the percentage of hydrogen. I'm going to think about another thing. We can go through either the percentage of carbon, if we want to check. If we want to continue, we can take the percentage of carbon. And another way is to take the percentage of oxygen or carbon, as I said before. So the point is, which one I'm going to pick? I'm going actually to go through the percentage of carbon. So what I'm going to do now, I will try to look for what is the percentage of carbon for A, C, and D. To find the percentage of carbon, this is another lesson, but we can link for how to calculate the percentage here by taking the molar mass of carbon over the total molar mass times 100%. So if I'm going to start with A, I'm going to find the percentage of the carbon. So it will be, how many carbons do I have? I have 2 carbons. 2 times 12, it is actually 24. So it is 24 divided over the total molar mass. I already know it before, which is 102 multiplied by 100%. We're going to think about the final answer later. For the C, to find the percentage by mass, so you're going to take how many carbons do we have? We have 5. 5 times 12, it is equal to 60 divided over 102 times the 100%. And finally, I'm going to go through the D into the D part. So I have 6 carbons presented. 6 times 12, it is 72. Equals to 100%. I will try a little bit to apply on math, and I will think about the final answer maybe in a simple way. Now you need to remember that you will be dividing 24 over 102. You're going to divide 60 over 100. There is a one common number in all of them, which is the division part. You're going to divide over each time by 1. So here there's a 1, and here there's a 1. So here there is also 1. Maybe in somehow you will try thinking in math what would be the possible decimal. Of course it will be a decimal. It's not a whole number at all. Since when you want to divide 24 over 102, it will become a 0, and there is a decimal right here. So in order to have this 2 and you have this 1, so approximately you will multiply by 2 actually in order to have a number which is so close to 240. So here as an approximate number, it will be a 0.2 something. I'm not going to continue. And if you want to focus on the 60, another time it will be 600 over 102. Since you have a 1, so it is another time something which is approximate by 0.6. And here it will be an approximate by 0.7. And of course, these are multiplied by 100. So there will be times 100. So it will be something as 22, 32, the same situation for the 6 and for the 7. But this will give you in somehow an approximate percentage of which one is the final answer. I'm looking for the carbon, which is 58.8%. So it is approximately as being 60%. So which one will give me 60 after multiplying by 100? It's my C answer. So my answer, it's the C. Of course, this question is not considered an easy question. And there is an idea of that. Because of that, I put it inside my lesson for today. I have now a third question. Inside this question, I want, what's the molecular formula of the hydrocarbon containing 84.6% carbon by mass with a molar mass of 142.3? Another time, my actual molar mass of the compound that I'm looking for, it's 142.3. If you look at this, you're going to find that the molar mass given, it is more precise since one extra decimal place is presented. So there is an extra decimal. So when I'm going to calculate the molar mass of each, I need to make sure of taking the relative atomic mass from the periodic table correctly. So if I'm going to start with the carbon right here, I'm not going to take 12. I'm going to take it as a 12.01. So I need to calculate the molar mass in a precise number. This will be a 284.64. Of course, it's so far away, so this is not my answer. Continuing with the second, the molar mass, it is 142, but the decimal is 21 right here. I'm looking for a 3. So I need to continue with the C. Calculating its molar mass, it is 142.32, which is so close to the number that I'm looking for. Finally, if you want to continue for the last, its molar mass is so far away from the number that I'm looking for, since it will be 76. So in this question, calculating the molar mass using rounded relative atomic mass, it will not help you to reach the final answer. So since it is given in more precise way, so you need to calculate the molar mass in a precise way, taking the whole relative atomic mass from the periodic table, section number 6, from your data booklet. And if you want to go through the percentages by mass, you can, if you want, to calculate the percentage by mass of the carbon and to check which one is 84.6, and it will be the C answer as well. What's the empirical formula for the hydrocarbon with 75% of carbon and 25% by mass of hydrogen? Here, I don't have the molar mass. I need only the empirical, so I need to go through step by step my calculations. So here I will take the mass, the same as the percentage, and we considered this before in our previous lesson, which is part 1 from the empirical and molecular formula. So you can refer for it another time if you want to remember how to calculate the empirical formula. If the percentages are given, we can consider them as being the mass. Now we will continue by the mole number. So you are going to divide over 12. And here we're going to divide over 1. 75 divided over 12. Of course, you need to do the long division. And as a final answer, when you long divide, it will become a 6.25. And here it's a 25. Then you're going to go through, divide over the smaller. So this will become a 1, and 6.25 divided over 25. Your final answer is 0.25. Now, if you've got a 0.25, you cannot round. As I told you previously also, you need to multiply by a number, which will be, in my situation, multiplied by 4. So the carbons, it will be 4, 1 carbon presented, and the number of hydrogens, it will become a 4, and your empirical formula is CH4. Of course, in this question, you have first way of thinking. You can go through the calculations. So this is the first way. If you are not familiar with dividing and the long division in case of having decimal, so perhaps this question will be little bit complicated for you. So I'm going to give you a small study tip. Maybe it will be easier for you when you want to decide your final answer. If you look at the numbers given, I'm going to find out the mole ratio, which is here 3:1. Here it is 1:2. I'm going only to erase the 2 and rewrite it another time to make it clear. Now I have the C2H6, I can rewrite it into an empirical formula. So I'm going to divide over 2, so it will become a 1:3. And finally, I have 1:4. If you look at the question, it's telling me that you have 75% of carbon and you have 25% of hydrogen. 75 and 25, it is as a percentage of 1/4. Since 1/4, it will give you the percentages that we have here. So you can go through this way of thinking. Maybe it will help you so far to find the final answer without doing the long calculations part. I have here another question also. This is from the new questions presented in the IB past papers. A sample of a compound contains approximately 24 grams of carbon, 3 of hydrogen, and 1.6 of oxygen. What's the empirical formula? Actually, here I need to do calculations. Maybe here it will be easier little bit. So for the carbon, you have 24. For the hydrogen, you have 3. And finally, here you have 1.6. I'm going to divide over 12. I'm going to divide over 1. I'm going to divide over 16. 24 divided over 12, of course, it's a 2. Here it's a 3. And here it is a 0.1. Now you're going to divide over the smaller, which is 0.1, 0.1, and finally 0.1. 0.1 over 0.1 is 1. 3 divided over 0.1, of course, you need to multiply above by 10 and below by 10. So your final answer is a 30. And finally, you have here a 20. Taking this into consideration, your final answer would be the A. And you are done. Now, question number 6 and question number 7, they are so important since we're going through the idea of carbon dioxide and water molecule presented by burning, but this time we're going to deal with it inside paper 1 multiple choice questions. So on complete combustion, a sample of a hydrocarbon compounds produces 1.5 mole of carbon dioxide and 2 mole of water. What's the molecular formula of this hydrocarbon? Since you have the mole number of carbon dioxide, it is already given. So I'm going now to start with mole of carbon, direct. So I know that the carbon is the same as the mole of carbon dioxide. Why is that? Since I have the same number of carbons. So it is 1.5. What about the mole of hydrogens? Since I have 2 hydrogens inside the water molecule, so I'm going to take 2 and I'm going to multiply it by 2, and your final answer, it's a 4 mole number. So now I have the mole number of each. So I'm going now to continue my calculations. So I'm going to put the carbon and I'm going to put the hydrogen. In this situation, my compound is a hydrocarbon, so I don't have oxygen. So I'm not going to deal with oxygen here at all. I'm only focusing on the carbon and hydrogen. So the mole number, it is 1.5. And here I have the 4. Now I'm going to divide over the smaller. So 1.5, here divided over 1.5. You will multiply by 10 and you will multiply by 10 in order to make the long division. So you will do 40 divided over 15. If you consider the calculations part in this situation, so in this part, you will start thinking, what's the number that I'm going to multiply by in order to have a very close number to the 15? Of course, you're going to find that in this situation, your answer, it will be for a 2, which is 30. Then comes minus, you have a 0, and you're going to have a 6. 6 times 5, it is 30, then 6 and 90, and so on. So your final answer is 2.66, and here you have a 1. Now you need to remember another time that if you have a 2.66, as you have a decimal of 6, as also I told you previously in our previous lesson, it's not allowed to round, so you're going to multiply by the number. And I gave you all the possible decimals that comes inside the exam. So here you're going to multiply by the 3. So your final empirical formula, after multiplying by 3, you're going to find that the carbon, it will be 3. 2.66 multiplied by 3, the answer, it is 8. If you want to go back to the options given, so your empirical formula is C3H8. Now there is another idea here, also taking into consideration the carbon dioxide and the water vapor presented from the combustion. When 50 cubic centimeter of hydrocarbon, so another time it is made only of hydrogen and carbon, was burned in excess oxygen, which is 200 cubic centimeter of carbon dioxide and 250 cubic centimeter of steam. When the question is telling you steam, so it's talking about H2o water vapor. And here you have the CO2. All volumes were measured under same conditions. What's the molecular formula of the hydrocarbon? Here I have an idea, and there is a link between this question and the gases part section, which is important also in topic 1, stoichiometry. There will be another lesson into which I'm going to explain the gases, their calculations, and we're going to refer to a lot of laws important in gases. Inside this question, I have 200 cubic centimeter. So I don't have the mass, I don't have the mole, but I have here a very important clue that will help you to assume something. Since all volumes were measured as the same conditions, so I can here assume the volume the same as the mole number of gas in cubic centimeter. The volume equal the mole. So if the question is telling me that I have 200 cubic centimeter of CO2, it's actually the mole number. And I have 250 of steam, so it is actually also the mole number. I will try to answer this question. So I have now the carbon, I have also the hydrogen. I'm going to put the mole number. I think now that you are familiar that the mole of carbon is the same as mole of carbon dioxide. Here it's the same as the volume. So it is 200. I'm going to put it under the carbon. For the hydrogen, I need, of course, to multiply by 2. So I have 250. And I'm going to multiply it by 2. So here I need to remember that this one multiplied by 2 in order to have the mole number of hydrogens. So your final answer is, of course, 250 times 2, so it is 500. Now I'm going to divide over the smaller. This is 1. 500 over 200, it is 2.5. Now I will multiply by 2. So your final answer is 2 carbons and 4 hydrogens. 2.5 times 2, sorry, it's a 5. So if I'm going to take my final answer, so it is C2H5. If you look back or you go back to the options, do we have C2H5? No, we don't. Remember that the final answer that we have obtained here is actually the empirical formula. It's not the molecular. The question is asking me to determine the molecular formula. So I'm going to look for one of the multiples of the empirical formula, or for the formula into which its empirical is equal to C2H5 and it is C4H10. Since if you want to write the empirical formula of this compound, it will be C2H5. So this is my empirical formula. And the answer would be D. For our lesson today, I'm going to end with this question, which is a very new question taken from May 2022. Inside this question, I have 30 grams of an organic compound produces 44 grams of carbon dioxide, 18 grams of H2O as the only combustion products. Which of the following is the empirical formula of this compound? If you look at the options, you're going to find that inside the options, there is a possibility of having oxygen. So in this situation, I'm not going only to focus on carbon. I'm going also to focus on the hydrogen and oxygen as well. So, and in this question, we have the mass. So we need to find the mole number, then to continue with the calculations of the mole of carbon and hydrogen. So let's start. We will start firstly with the mole of CO2, which is 44. You will find that all the numbers, they are easy. So they are simplified easily. So this is, of course, one mole number. I'm going to continue on having the mass of the carbon. Since it's the same mole number, so it is 1 multiplied by the molar mass of the carbon, which is 12. So I have 12 grams. I'm going now to deal with the water. So I have the mole of H2O. I have 18 divided over 18. It's another time 1 mole. But for a mole of hydrogen, I'm going to multiply by 2. So it will be 2 moles instead of 1. Now I will find the mass of the hydrogens another time. I'm going to take 2 multiplied by 1 as a molar mass, which is 2 grams. Here, I'm going to take the 12 gram and I'm going to take also the 2 grams in order to find the mass of the oxygen. So, continuing with the mass of oxygen, the total mass of the sample given, it is actually 30. So I'm going to subtract from the total mass, which is a 12 plus 2. So 30 minus 14, and your final answer is 16 gram. Now continuing with the mole of oxygen. Of course, you will take your mass as 16 and you will divide over 16 and your final answer is 1 mole. I'm almost done. So now I'm going to put the carbon, the hydrogen, the oxygen beside each other. I will be taking the mole number and then divide over the mole ratio. Going back to the mole, I'm going to find that the mole of carbon, it's the same as the CO2. So it's a 1. Remember the number. Mole of hydrogen, it's a 2. Finally, the mole of oxygen, it's a 1. So I'm going now to put the numbers. the carbon is 1, the hydrogen is 2, the oxygen is 1. So my empirical formula is CH2 and O. Going back to the options, the answer is D. I'm done with my lesson for today about empirical and molecular formula. This is the last practice question. If you take both lessons, empirical and molecular formula, part 1 and part 2, in these situations, I covered for you all the possible ideas from past papers taken for paper 1 and paper 2. See you in another lesson.